Hello everyone. So last time we left off with our instancing where we created a lot of instances of trees, and this time what I want to do is just create an enemy, and this will be my last video in this series because well, yeah, we covered most of it when it comes to graphics, and I think the further you go from here the more you can take on. But anyway, let's get back to the video and what we're going to do. And we're going to use this enemy, which I downloaded from OpenGameArt. So you can throw shout out here. And I'm going to leave this in the description of the video. And shout out to Author5 for creating them. Anyway, we're going to use them, and we just want to have an enemy that follows us around. Nothing too special, but I just want to showcase how can we do that. This won't be too complicated, I guess. We can just go to our game objects and then create a player. Let's get immediately to it because there isn't too much. Oh my, not player, enemy. There isn't too much to explain here. What we're going to do is just modify our vertices from time to time to update animation. So what I want to do is, in our enemy, I'm just going to be lazy, copy the decal here and then rename it. Because here what we're going to do is just move stuff around and delete it as we see fit. So we're going to need three textures because I have three images here. The first one is, let's go with sort of idle animation, which is Progmon, and be mindful here it's not Progman, it's Progmon. It's called stand, and I'm just going to image stand. I'm going to copy over it and then just create two others, which are walk and die. So let's do that. We're going to need that. Walk and then image die. So vertex buffer we do need. We do need this index buffer as well. So that's all good. Transform data, I'm going to leave it as an array, although we should only have one technical. But if you want to expand it and have multiple elements, you can do that. But for now, I'm just going to leave it to one. And it could be just single transform matrix, but then I have to like change our update buffer, and I don't want to do this. This I would have to change this transform buffer, right, which is instance buffer. Right now it's not important. You can do that in your own free time. But let's go further, and then let's just get texture stand. So we need three textures as well. Let's go call this walk and die. Maybe better name here would be idle, but yeah, not super important. All right. Going from here, let's just see what do we need here and what we can remove. So we're going to need terrain information, which we have right here. We don't need this random though. We're going to use it whenever our guy walks, right? Our enemy walks. We need height information from the terrain. So I'm just going to reuse this, and I'm going to move it to update because here it does make more sense, and that means also that this terrain we need to save it into some variable, which I'm going to call here terrain, and I'm just going to set it to now, and we're going to need it here, terrain, although not like this, of course, this terrain. Okay, cool. So we're going to need that, and we can play with this bit later, or we can do it now. So our x and our z are just going to be some property that comes from our position. Basically, maybe not the best, but we just need vector 2, and the height is going to be determined by the point on the terrain. So we're looking at length and width of the terrain, right? So it's somewhere on the x or z coordinate. So what we're going to do is this, and we're just going to call it position. And by default, it can be vector 0, 0, I guess. I mean, yeah. All right. And so here, since we're using that, actually, we can just say position.x. and position.y. We don't need times 64. Why is this problem though? Haven't we saved our terrain? I have this thing, it's a bit weird that it doesn't recognize it. Ah, okay. Let me check this quickly. Anyway, it should be there. Maybe it's just right there acting up. But anyway, let's go here. So we had terrain width, and that's fine. So let me just think here for a second. We're going to need to offset this, right? Because here our terrain is centered at our origin, right? But our data is not centered around origin. It goes from 0 to 64 and our terrain goes from minus 32 to 32. So we're just going to need to increase this, right? Then get the z and x, and this remains the same, right? We're just getting the terrain index. So this, because we increased it, we need to decrease it when we create the matrix. And this can just be 4. We're going to play with this matrix a bit later. But I think this is fine, and I'm just going to find position on terrain. All right, we're going to need this bit in the future. But for now, we can initialize the texture because that's the easy part. So texture stand, right? Init textures. And here we're going to say image stand. And then we need to repeat it 3 times for the 2 other ones. So I'm just going to texture walk. So here is image walk. And this one is texture die. Correct. All right. And image die. So I'm just going to do this so that if I need to debug something, I'm sure that all are correctly assigned, and that's good. And by default, we can just have our texture stain. Good. Now that we have textures, we can start thinking about this buffer because we're not going to use this geometry here. Why is that? Because we're going to need to write to it, right? In order to update our animation. So let's get rid of this quad geometry. And then I'm just going to add a couple of methods here. The first one is just going to be a very simple one. And I'm going to call it private void setup vertex data. Right, but we still don't have this vertex data, so let's actually create that. So here, what I'm going to need, let me check this. So we're going to need private float. It's going to be float array. Then we need data, a new float. So we're going to have 3 for our position, right? X, Y, and Z, plus 4 for our color, right? If you remember from our vertex, and plus 2 for our texture coordinates, and then times 4. So 3 floats for position, 4 for color, 2 for texture coordinates, times 4 for number of vertices for Y, right? Index buffer, we can just pass it in when we create this, and we can do it right over here. So our indices, we're just going to go, let's see, I imagine it will be top left, top right, bottom right, and then bottom right once again, bottom left, and 0. So this is how I assign this setup vertex data. So let's try to do that. First of all, we're going to need our index. And what did I say? Top left. So we're going to have top right, bottom right, and then we're going to have bottom left. So I need to write vertex data here, but we can do that a bit nice. So we can just create write vertex function, and then we can take that index in as a reference, right? Because here we're going to increase it, so need that information back. And here we can just say float x, float y, float u, and float v. So we're going to just write x and y position, and then texture coordinates. All right, and here you can just say index plus plus equals x. So here I made a mistake because this is not going to be y. No, it's fine. It's fine. I'm just thinking way ahead of myself. So just to explain what I wanna do. So what I wanna do is just have a simple quad for our enemy. It's still going to be sprite. I haven't even mentioned it, but it's just going to be basically a billboard similar to our trees. But we're going to have 1, 0, and 2 here, right? Top left, top right, bottom right, and then we have index here as well. So we created first triangle of this tree, right? And then I went and connected this tree. So this is second triangle. So we're just going to have created right over here and here. All right then. And how do I clear this? I forgot. Okay. All right, Z we don't care about. Then we're going to have our color, which is just going to be by default all ones. If you want to pass color here, you can. I'm just going to use this as all ones, because this is data required by our shader, if you remember, and this is fine. So we're going to have top left. So let's write that vertex, and let me see this suggestion, minus 0.5, 0.5. Is it the 0.5? Yeah, that's top. That's fine. Then top right. So let's do this once again. Ref I. And here it's 1, 1 now, and the float UV is 1. Sorry. Yeah, it's 1, 1. And then, okay, no, my bad. 0.5, 0.5. So bottom right, we just need to change this, right? And then we need to change this to 0 as well. And then bottom left, I guess both. Here x is minus 0.5, y is minus 0.5. And then we have 0 and 0 for u and v coordinates. And that's basically it. We're going to handle animation a bit later. For now, we can just leave this. And I guess because we're filling the data here, that's fine. Here. So what does this ref means, right? It means that this index value here, it's going to be increased. Here we increase by 9 components. So once this is over, index is going to be 8 or 9. All right. So we not just need to set up vertex data, and we're going to do that actually every frame. Not right now though. We're going to handle a bit later. So vertex buffer is our data, and vertex count it's always going to be 4. So we can just hardcode that in. That's good. That's most of the stuff that we need for our enemy. I still don't know what's with this, and let's just get rid of those textures here. All right, let's try and create finally our enemy. So in our scene, we had terrain scene, and I'm just going to put it over here. Enemy. Oh, what's happening? Here now it knows the enemy. I guess it was just Rider acting out. Alright, we just need to initialize that, and we can do it right over here. So our enemy dot initialize, and then we need the camera and terrain. Of course, we need to update it as well, so we can do that here, and then we need to draw it as well. So I'm just going to do that here. Good, and if I try to run it, let's see what will happen. Okay, good, it actually works, although I cannot see my enemy at all, which is weird. Is he somewhere on the edges if I miss the index? You know what? Let's try this again. Let's go to our enemy, and I'm just going to make it considerably bigger, because maybe it's just too small so that I don't see it. Of course, I updated this here. First of all, we don't need array anymore. This is unnecessary. We just need this, and let's quickly reformat that. Okay, that works. But now I just need to update it, transform buffer with transform data, and here we're saying let's update that instance 0, I guess. Oh no, it actually takes the matrix, even better, so we can get rid of an array here. So we need this transform data or transform matrix. We're going to use that. Here we need an array. All right. When we initialize it, we need an array, but here we can just update the transform matrix. And it's good. Cool. Now it might work. There it is. It's upside down, which is so nice. It's kind of funny. But let me check that out. Why is it upside down quickly? Of course, it's upside down because of the texture coordinates. So here I wasn't sure of this while I was typing it. So it's 0, 0, 1, 1. So if I try to run it now, it's going to be fine, probably. Yeah, it's fine, although it looks kind of ugly and has this line up here, and that's probably because we use bilinear filtering by default, so we can just change this to use nearest filtering, and then it will be sorted out. So let's try to do that, and then it's somewhere in the texture or my util class. So not this util. Let me just check quickly. WebGPU utils. So wherever we create a sampler, we were usually creating it with linear mode for filtering. So let's just use nearest because that works better for games that use like pixelated art. So if I try to run it now, it should look way better. Yeah, it does. It does. Okay. So we obviously need to reduce its size, and then it's probably fine. So let's go there. And let me just see my notes, because for size I'm not sure what I used. So it was 2, 2. Right over here, it can be just 2, 2, and then here. The one is also that worked really nice for me. So if I check it now, it's a bit here down. All right. All right. I mean, this hill is really up, so maybe that's the problem. Let me just quickly check this. Yeah, I guess it might be fine once we start moving it. So let's actually work on that. Let's try to move this character around. So for that, it's very simple. So we just need position, and then right over here in our terrain scene, in our update. So we can do this. So let's try to do this. We're going to have vector var direction. So direction which we want to go is our player, right? We're going to need position from our player minus, and then our enemy dot position. So let's just create position for our player. Public vector to the float position, and then we can just have get and private set. That's fine. And here we pretty much got position, right, when we needed to move it. So we set it to our camera position. So we can just set position here, and it's going to be from our position here. We take X and we take Z. So I didn't take Y. You can take that, but then you have to do a bit of casting there because I used vector 2 for enemy as well. But let's try to check this, and if I go to our terrain scene, so we now have direction, and we can just say enemy dot position plus equals, or just equals enemy dot position plus, so this direction. Although we don't need to normalize it, so I'm just going to use vector 2d, and I'm going to explain it in a second because it's very easy math. And then we can just say times 0.01, and I just want to check if this actually works, if the enemy is following me. And if that works, I'll just take a second to explain it. Okay, I don't see him anymore, so it means he's nowhere to be found. Yeah, okay, let's try this once more. So this is all right. I can do just plus equals here. Direction. Ah, of course. So what happens is this might be 0, 0, right? So we just need if direction. So what happens is if they're exactly the same, you're going to get not a number, right? When you try to normalize this, I guess. So we just need to do length or length square, because it's cheaper to check length squared, is greater than 0 or does not equal 0. I guess it's fine enough. I think it will be fine now. Oh yeah, there he is following us. He goes toward us. And here it has a bit of a jerky motion because we clamp our indexes. So I'm not going to do this in this video, but you can linearly interpolate between, you can find like the next potential position of this enemy, and then try to interpolate that. I'm not going to do that, but I promised that I'm going to explain this, and this is very easy because it's just 2D. So let's say we have our player, let's say we have our enemy, right? And how do we get to our player? Well, we just take player minus enemy, and we're going to get this vector, right, over here. But then I decided to normalize it, so it's going to normalized vector is going to be something like this, right? It's going to have a unit length of 1, but then I scale it big down so that our enemy goes in incremental steps towards the player, right? And at some point, if you don't move the player, it's going to reach the player. Okay, okay. So further, we just want to do animation, and then we're pretty much done with this video. And animation is really easy, and so it's not that hard. It's very easy to do. Let's just go to our enemy. So first of all, I'm just going to have public in animation state, and then we're going to have stand, walk, and dive. And then further, we're just going to need some properties regarding animation, and you're going to see where I'm going with this. So first of all, we need that animation state. And then I'm just going to call this actual animation. And let's immediately set it to like walk. Then we're going to have public animation state. We're going to have our getter and setter. You're going to see why. So we're going to need two indexes related to our animation, or three. So first of all, we need total frames of animation. So we're going to set that here when we set the animation, but we also need current animation frame. So private integer current frame, and we always start at 0. And then we also need current animation time, because we want to change animation once it reaches some threshold. And I guess I can just create those thresholds here. So we're just going to have a constant float frame change time, right? And it can be 0.1. And then we can also have simple scalar for our animation. Float animation speed. And I'm just going to set to 0.1f. So whenever we reach here, we just change to next frame. So basically we have frame-based animation, meaning, well, let's try to quickly draw this if I can. So let's say we have some 4 frames, right? We're on frame 0 when we reach this frame change time, right? So we're adding to our some current time. Right, when we reach it, we just flip here, then flip here, and then we just go back to the beginning. And that's how our animation will work. So let's try to code this. And here I'm just going to have a couple of states. First of all, we need to set that animation value. But then I just wanna, whenever we change animation, I just wanna change the current frame to 0. Not time, current frame. And then we're going to have if this animation is equal to animation stand, how many frames do we have? We have total frames is 1. And of course, I need to remember to change the pipeline texture as well, right? So it's our stand, texture stand. So let's just take a look at here. So here we just have 1 frame, right? Very clear. Here, if I zoom in, we have 4 frames. And then for that animation, we have 5 frames. So it means else if animation is equal to animation state walk. What did I mention? We have 4 frames. So here we're going to have 4, and then this is going to be walk. And if we die, we have 5 frames. And then the texture is texture die. And that's it for this setter. So we just need to handle this animation, and we're going to handle it right in our update. Let me just see, how are we going to do that? All right, here we're going to have our animation. So if our current frame time, current animation time, right, is greater than frame change time. So what are we doing here? Well, we're changing the frame. So we just need to restart that time. We go from 0, and then current animation, current frame, sorry, plus, right? And then we just need to handle what if our current frame is above total frames. So if current frame is greater or equal total frames, we just need to restart it. Right over here, right? That's very simple. But here I'm just going to call setup vertex data. And then we need to update that vertex buffer with vertex data. Okay. We don't need its length, I guess. And here we can just say connect animation time plus equals animation speed. One thing that you're going to notice here, and it's very crucial that you add that if you're writing your engine, and that's delta time. I never handled it here, so it's entirely dependent on your CPU speed. That's obviously not ideal, and you would want to have like something like delta time. I don't have it here, so maybe your animation will play faster or so on slower than mine. Probably will, but it's because we're not multiplying it by delta time. So just so that you're aware. And in the setup vertex data, we just need to set this up a bit. So we have all of this information that we need. So idea is we're just going to set up this texture coordinate, specifically this U coordinate, right? Because our frame just goes from left to right. So here the texture coordinates is going to be something like 0 to 0 0.25, right? 0 0.5, 0 0.75. And then we take 0 0.75 up 0 0.75 up to 1 here. For here, it's going to be from 0 0.25 to 0 0.5, I guess. So that's our enemy. We just need to handle that, and that should be very easy to do because we have all the information. So I'm just going to call this texture coordinate step, and it's 1f over our total frames. Very easy. And then we can just have float u, which is our connect animation frame. Connect frame, I called it, times texture coordinate step, right? So we just need to pass u here. Since this is 1, this is u plus right texture coordinate step. Here it's exactly the same, and here since it was 0, it's just u. Now, I guess if you had 2 rows, then you would need to handle this as well. But since all my animations are in single row, this is totally fine. For 2 rows, like I mentioned, you would probably have to handle it a bit differently. But let's see further. Do I need anything else? No, I think that's it actually. If I just try to play it, maybe we'll have something good. Let's see if our player is following us, but he's not playing animation here, and that's because, of course, I did set it here. But that's not going to work because it never went through a setter. So we need to use a setter to set up our total frames properly. And here I'm just going to use walk. So now it should work a bit better. Right, texture walk is not initialized. That's weird. Let's see, did I do something wrong? Aha, of course. It cannot be here because we initialized textures here. So let's just leave this somewhere towards the end. Of course, it can be set from the outside as well. And this is all wrong. And I have feeling what it might be. So here we paste everything correctly when we update it. So probably means that something is wrong in our update. At least it was while I was preparing for it. And it is. We cannot just use data length, right? Because it needs to be in bytes. So we just need size of float, right? So here we said this is optional, and if it's not passed, right, if length is -1, we're using data length. But obviously that's wrong because it needs to be in bytes, so we just need to multiply by bytes. Same as here, right? So if I try it now, I think it should work properly. And it does. As you can see, our enemy is moving towards us. He's very slow though, which is annoying. So I'm just going to make it a bit faster. Let's say by factor of 5. And there he goes. He's chasing me way too fast. Obviously, he's going to go through geometry like these cubes, but you can actually handle that. You can try to add physics to this enemy. But for now, I think it's fine, right? So you can also play with the die animation, and that's it. How you can actually do animation, right? You just need to recap. Basically, what you need is just to update these texture coordinates, and that's it. All of this which we set up here was just in order for us to update the texture coordinates. Right, and we do it every frame. Right here, so we just have basically frame-based animation. We increase the current frame, we set up the vertex data, which just increases the texture coordinates. That's it. Hopefully it wasn't too hard. With that said, this is my last video for this series. I'm going to make some other video which I'm going to talk about some stuff way more. But that's it. Hopefully you will be able to like pick from here and then do your own engine stuff with WebGPU. For the next series that I want to do is just DirectX 11 probably. And in C++, so I'll start preparing for that. And if you enjoyed the video, please like, subscribe, maybe leave a comment, and until next time.